warahmatullahi wabarakatuh. Hello students, how are you? I hope all of you in a good condition. Okay, in this video, we will continue our lesson about chemical bonds. Before we enter the material, I will remember you about our lesson last meeting. So, students, have you remember our lesson last meeting? Yes, that's right. We learned about electron configuration. Electron configuration is the distribution of electrons of an atom or molecule or other physical structure in atomic or molecular orbitals. Electronic configuration describes each electron as moving independently in an orbital in an average field created by all other orbitals. Mathematically, configurations are described by Slater determinants or configuration state functions. Knowledge of the electron configuration different atoms is useful in understanding the structure of the periodic table of elements. This is also useful for describing the chemical bonds that hold atoms together. Okay, students, in this meeting, we will learn about two topics in chemical bonds. First, the tendency elements to be in stable state based electron configuration. The second, we will learn about the process of elements can be form a compound based ionic bonds.
Living things in this world, like forests, flowers, insects, or anything in this world are made of atoms.
But in most cases, these atoms are not just floating around individually. Instead, they are usually interacting with other atoms or groups of atoms. For instance, atoms might be connected by strong bonds and organized into molecules or crystals, or they might form temporary weak bonds with other atoms that they bump into or brush up against. Both the strong bonds that hold molecules together and the weaker bonds that create temporary connections are essential to the chemistry of our bodies and to the existence of life itself. Now I will ask to you, why form chemical bonds? Atoms are trying to reach the most stable low energy state that they can. Many atoms become stable when their valence shell is filled with electrons, or when they satisfy the octet rule or duplet rule by having 8 or 2 valence electrons. If atoms don't have this arrangement, they will want to reach it by gaining, losing, or sharing electrons via bonds. Now we enter the material about ions. Some atoms become more stable by gaining or losing an entire electron or several electrons. When they do so, atoms form ions or charged particles. Electron gain or loss can give an atom a filled outermost electron shell and make it energetically more stable. Ions come in two types. First, cation and the second, anions. Cations are positive ions formed by losing electrons, while anions are negative ions formed by gaining electrons. This is a video about ionic bond, especially about the process how elements can be a compound. Ionic bond is transfer of electrons from a metallic atom to a non-metallic atom. This is atom sodium that we have with atomic number
11. An electronic configuration base cell 2A1. Sodium has an extra electron in its outermost shell. And this is atom chlorine with atomic number 17. And electron configuration base cell 2A7. Chlorine needs one electron or gain one electron to complete its outermost shell. Sodium has an extra electron in its outermost shell. When sodium reacts with chlorine, what will be happen? So, sodium donates electron to chlorine, and sodium becomes positively charged ion, sodium plus, while chlorine achieves an electron from sodium and becomes negatively charged ion chlorine. This is how the process of ionic bond. Oppositely charged sodium and chloride ions are held by a strong electrostatic force of attraction known as ionic bond. This is the reason why sodium chloride can be a compound. Okay, this is our conclusion about our materials. First, about ions. Ions is an atom that tends to release or receive electrons. For example, sodium and chlorine. Sodium will release one electron and then be an ion sodium plus, while chlorine will gain one electron and then be an ion of chlorine. The second conclusion is about ionic bonds. Ions sodium and chlorine attracted each other by a compound, sodium chloride. Sodium transfers one of its valence electrons to chlorine, resulting in formation of a sodium ion with no electrons in its third cell, meaning a full second cell, and a chloride ion with 8 electrons in its third cell, giving it a stable octet. That's a combination of ionic bonds. To test your understanding of chemical bonding materials, especially ionic bonds, let's consider the following questions and try to work them. Because this is the end of the topic of chemical bonds, I hope all of you can understand it. See you later and Assalamualaikum warahmatullahi wabarakatuh.